tangent of 0 is 0. Okay. So this first one would be 1 over, and then this is written poorly, but I guess it's almost like the tangents on the bottom. I get. So I think this is meant to be like this. Okay, and then that would be 1 over 2 times 0 divided by 0 is not possible. So that's why I think that one's out. One. This isn't right either. Sorry, it's just these aren't formatted correctly, so it makes it really hard to know what to tell you here. Okay, let me try something else here. So these aren't right. So tangent of x, okay, it is sine x over cosine x, and we have to figure out where is the bottom equal to 0. Well, cosine is equal to 0 at, if we graph it, right, it comes down, comes back up here and here. That's pi over 2 and 3 pi over 2. Okay, so that means that the tangent graph has an asymptote at pi over 2 and 3 pi over 2, and that's what they're showing here. It also goes the other way. So it's either this one or this one. Okay, and then the question is, well, does it like what happens over in this region or this region? Like which one is it? So when we go back and look at the graph of tangent, the sine and cosine, they're positive in the first quadrant. So that's why tangent looks like this. And then negative tangent looks the other way. So this is positive tangent and this is negative tangent here. So a long way of saying the correct answer is 3.
Just 1/2 10, not the negative, right?
Yeah, not the negative one.
They put it as incorrect for some reason.
Well, okay, yeah,
we're spending a lot
of time on these jacket ones that I would just tell you to go to Desmos and graph and move. You know, there's, if you have a calculator, you can graph it that way as well. So did you choose number 3?
Yeah, I chose number 3.
Oh, okay. Well, yeah. So number 3 is going the other way. Sorry. So number 3 is going that way. Number 1 is the one that this is, because of the flip. So.
Just said the second one.
Okay.
How do you find the period? Is it just 2 pi over b?
It depends on whether it's a sine, cosine, secant, cosecant, tangent, cotangent.
If it's just sine, cosine, is it just 2 pi over b?
It is 2 pi over b. Yeah, that's number 2 there.
That's great. Just on the third one.
Okay. All right, got it here. Okay, what is the period of this graph? So the period is, you have to figure out like what peak to peak is. And in this case, let me snip it in here. Okay, so peak to peak would be like how far is it from here to here? And that's pi over 2 and then 0. So you take pi over 2 and subtract 0. So peak to peak is pi over 2, and that is your period. It's peak to peak is what I'm trying to say there.
All right, that is correct. I'll send you to the next one.
Waiting for that to come in.
Is it
There it is. Got it. Okay, so we're looking at what are the two asymptotes for the given function. Okay, let me snip that in. The so what you're looking for is where the denominator, the bottom, equals 0 of the given function. So the given function is 3 tangent 2x. Okay, 3 tangent 2x, and that is the same as saying 3 sine 2x over cosine 2x. And the asymptotes, really they're asking what the vertical asymptotes, that's where the bottom equals 0. Where does cosine of 2x equals 0? So the best way you can do this is you actually say, okay, where does cosine u equal 0? Where is that happen? So again, if you just get a graph of cosine, it starts high, goes low, comes down, comes up, and so on. These 2 points are pi over 2 and 3 pi over 2. If you go back the other way, right, it's minus pi over 2. Okay. The problem
okay?
though is that we're not doing it for u, we're doing it for 2x. So if we say, oh, well, u is minus pi over 2 and u is pi over 2, the problem is we really need to do it for 2x because u is really 2x minus pi over 2. 2x equals pi over 2. Solve for x. So x ends up equaling minus pi over 4. X ends up equaling pi over 4.
Okay. I see what you mean. That's understandable. So minus pi over 4 and then pi over 4. That's correct. Plus, excuse me.
Okay, there's a new message. All right, you got what is the equation of this graph? Okay, so do you see how this graph starts at 0 and then goes up? That
Yeah, I
means
see
it's a
that.
sine. It's a sine graph. So that gets rid of 2 of the options. What's the difference between the first and the third equation?
Oh, one has a 2 sine 2x, one has just the 2 sine x.
That's right. So the only difference is that number there. It affects the period. So like this one has a period of 2 pi over 2, which equals pi. This one has a period of 2 pi over 1, which is 2 pi. So now if we go sort of from where we started to where we end, how far is that? And that's another way to do periods. It's pick a position and get back there. This is pi. So this is the period right there.
Yeah.
It's the horizontal distance until you get back to where you started. So that's why this one has to be correct, because it has the right period that goes along with it.
Alrighty. Let's do the next one.
Okay, see a new message has come in from you, new email. All right. Which function matches the graph? Okay, so this is better, I guess, that we look at this. So um, all right, so I'm looking at the graph here. They're all tangents, and tangents by themselves, we learned earlier, they all go kind of up and to the right, and that's what happens here. The hard thing to do is to figure out, well, which one is it. You'll notice the difference here is they all have a different period.
Yes.
And the period here is actually pi over b, not 2 pi. So this is like pi over 1/2. This one is pi over 2. This is pi over 1. And this one is pi over 4. The other sort of challenging thing here is that the graph is in degrees,
Degrees.
not or radians. So what I'm seeing though is that, and this is where it's a little bit on, maybe since you haven't seen it before, the width here, this is the period, the width between these two lines, that is 90 degrees. That is pi over 4, and that is supposed to be the period.
Mm-hmm.
So that's why it matches up with this one. So the vertical asymptotes are what define a period for tangent and cotangent.
So that one was incorrect. 4x. Is it supposed to be tan 4x?
Yeah.
I put it in and it said no.
Well, do you want me to try to confirm that, or we move on to a new question?
How would we try confirming it first?
Okay, so I'm gonna graph this. I'm going to graph tangent of 4x. The problem, though, is that Desmos doesn't like that, so I have to convert that to degrees. And tangent 4x is times 180 over pi. Doesn't like that either. Okay. Okay, so pi over 4. $45.45. Okay. Okay, so the just trying to get this graph here. Pi over 8. Huh. Um, well, I don't have a good answer for you because like everything I'm looking at says it should be tangent 4x, maybe 8x, but let me try one more time. Pi over 8. I guess go tangent 2x. That's that'll give you what you want on this one. So they must consider 2 of these to be a period. Oh, I'm sorry. This is 90 degrees. Okay, there's the mistake. Okay, you still there, Jack?
I'm here.
Okay, so the issue is that I wrote 90 degrees equals pi over 4, which is not true. 90 degrees is pi over 2, and that's why this tangent 2x is right, because I gave you the wrong angle.
All right. So I'll do the next one. Let's do a screenshot. This next one. Here we go.
All right, do you got a new question coming towards me? Coming by email.
Yeah, it's on its way. Just a sec.
Okay, there it is. What is the period of y equals minus 3 sine x? The period is 2 pi over b. Y equals minus 3 sine x. Period is 2 pi over b. B in this case is that number right in front of x, 2 pi over 1, which is 2 pi.
That's correct. Since it's a review, it gives me a little power-ups or whatever, so if you don't across this tricky question, I can use it. This one just gets rid of half of the wrong answers.
Okay, so what are we moving to next?
Just sent it.
All right, great. Okay, so we got more questions here. What would you multiply the angles x values by and the y values by to graph this? Okay, so they're asking for the transformations of this graph, or of this from this function, from the parent function, and it's it's a couple things going on here. You first start with the 1/4 on the inside, so that affects because it's on the inside part of the function. This affects the x values, and because it's division by 4, it ends up having the effect of multiplication. And you multiply by the reciprocal of this number, 1 over 1/4, which is 4. So that gets us down to, this one. The -2 affects the y values because it's on the outside of the function. So this is inside, this is outside. And you multiply the y values by -2. So that's why that green one is correct.
And that is correct. Sending another one your way.
Okay, great.
Is this one just going to be pi once you get it?
Just got it here. The period is 2 pi over 2, which is pi.
Given the graph below, the amplitude of the curve is okay. Here we go. How do you calculate amplitude again?
It's the absolute value of the number in front of the sine or cosine, or secant or cosecant.
Just said the next one.
Okay. Okay, the amplitude. So the problem here is that you don't have the absolute value. You don't have the function. So it's the max plus the min divided by 2. I'm sorry, max minus the min divided by 2. I can clarify that here with the formula. Let me just get it snipped in. So you got to figure out where the highest value is.
This one 4 or something?
4, yeah, 4, and then you subtract the smallest value.
This is 0, right?
Yeah, so the amplitude is the max minus the min divided by 2. In this case, it's 4 minus 0 over 2, which is 4 over 2, which is 2.
All right.
There's also a vertical shift that you could figure out, but this
What's the reciprocal? Secant is the reciprocal of what function? Is that
cosine.
tangent? Oh, cosine. Cosine. All right.
1 over sine is cosecant. 1 over cosine is secant. 1 over tangent is cotangent. There's 3 of those.
Just information.
Okay, there it is. Which function below matches the graph? Okay, the way to do this is to connect the min and max of the graph there.
Mhm.
And if you're doing this on your phone, I mean, it's really small, but it starts, what I mean is you connect that one with that one with that one and so on. And what is that the graph of? Well, it starts high and goes low. So that's the graph of a cosine. Okay. Is that all right?
And then you look for the reciprocal, right?
Right. So that means it's either this one, or this one. It's not the third one. Okay. This one right here has a 2 minus in front. That would flip it and move it up by 2. That one's out. So we're down to these two. We're down to, and the only difference between this is the period. This one has a period of 2 pi over 2. This one has a period of 2 pi over 1, which is 2 pi. So how long does it take the sine to repeat? So it starts here, comes down, goes back up. Can't really see that, but we'll assume it's around pi for that, where it comes back. So that's why this one looks to be correct, because it's got the right period to go along with it.
That's correct. Last one.
Okay, there it is. Which function matches this graph below? Okay, this one is it's all right, we're gonna grab this. Okay, so the graph here is critical here. this is really important. The fact that it has an absolute value, I'm sorry, of asymptotes here at pi over 4, that tells you your period is pi over 4. So which of these 4 has a period of pi over 4? Well, the period is 2 pi, I'm sorry, it's pi over the number in front. So pi over 1, this one's not written properly, this is pi over 4, and this one is pi over 8, and this one is pi over 1. So the first two are out. This one is correct. This is pi over 4. Cotangent does go down like this. The problem is that's not just a good enough reason to select, because tangent goes up and to the right, but if you do a negative tangent, it flips, and same thing with here. A negative cotangent flips it as well. But the short answer is because the period is pi over 4, that this is the correct answer, because you're just looking to distinguish between the period.
All right. No, I want to move on to a little bit of physics. I just want to get like a couple in.
Okay.
Well, so I guess taking a little bit extra time for some reason. I gotta sign on in. For some reason, it's being stubborn.
I'm trying to get back to where I've got some of these questions all ready to go in case they're out of the textbook again.
There we go. I think I just want to do like one of these and we'll be done.
Okay. All right. So she sent. Oh no, that's not you. Got something else. Okay. Still waiting for it to come in. Okay, got a question that's come in here. All right, object with mass 3.3 is executing simple harmonic motion attached to a spring with spring constant 310 Newton per meter. When the object is 0.021, it's moving with speed of, okay. So this is the simple harmonic motion unit of your book. It's kind of like trig in some ways, because you end up getting a trig function out of this. So there's all these formulas that go along with this kind of motion. Let me get those. Let me get those up here. That will make this a lot faster. So okay. This one's okay. Is this kind of an early on question or a more difficult one in the unit?
This is kind of a early on question.
Early on question. Okay. So the amplitude is equal to the square root x naught squared plus v0 squared over w squared. Maybe you've seen that in class. So we have some of those values. We have v0, we have x0, and we can calculate w.
Yes.
So w is the square root of k over m. And the mass is 3.3. K is the spring constant, that's 310. So we get that number, whatever that number is, and then we put it back into this equation. So amplitude equals 0.021 squared plus v0 squared, which is 0.45 squared, over whatever we get from that previous part here. So let's get that number here for you. W, which is it's the same as in the previous section. It's the angular acceleration or angular velocity. It's 310 over 3.3 square root of that. So it's about 9.6922. Always got a few more decimal places than you need, and I'm going to use that number in the next part of this. So it's the square root of 0.021 squared plus 0.45 squared divided by the value for W we just found. So that ends up being 0.051, and that's in meters.
0.75 meters, correct?
0.051 meters. 0.051 meters.
All right, that's correct.
Okay, now next part of the question says something about let's see, calculate the maximum speed. The maximum speed. Okay, so the maximum speed, Vmax, this is again just another formula here. This is for part B, is W times A. So big surprise that we're using W. So we take the value that we found in part A, kind of that intermediate step, and then that value we just found for A, and we multiply them together. I got to go back to the calculator to make sure I get the right numbers, but it's W times A. So that's 0.494 meters per second. Does it say how many units here? So probably 0.49 meters per second. We'll get it done.
That's correct. All right. I'm gonna pull up another problem. Here we go. Now I'm sending it to you. They should be sending now.
Okay, checking as always. Do you get a spring break coming up here soon?
Until the beginning of April.
Ooh. Okay.
Yeah, a whole month of no breaks.
Yeah, I guess you got a brief one for rodeo break. Okay, that one came in. Okay, 3 images. All right, so part A, part B, part C. Okay. Consider graph A, figure 2. I don't have these. So I can just look for the answers if that's what you want. I don't have the graphs here to. There's little sliders next to the figure. So,
apologies. Sending that right now.
Well, the thing is, these are all odd lines, so I could probably find them for you. So let me just do a quick search here. Okay, so the first graph looks like it's position versus time. Because I think it shows like it's kind of moving. Yeah.
That's correct.
The next graph is force versus position. Should look like a straight line potentially.
That's correct. That's one.
The third graph is velocity versus time, and it's like it's initially at its maximum, and then it drops down to almost no velocity when it stops moving, when the spring compresses it.
Awesome. Let's see if we can get one more done.
Okay.
This one should be relatively simple. Oh my god.
Okay, I see something's come in. Okay, how long must a simple pendulum be if it is to make exactly one swing per 5 seconds? That is, one complete oscillation takes 10 seconds. Okay. So the idea is like a pendulum swings left or it swings right, but then it swings back the other way. So there's a formula here. I mean, this is not like a something that you would just know. There's something that has to do with the length of the pendulum and the period. All right. So the period here t is 2 pi square root L over G. If you solve this for L equals T over the pi. The G goes up top, and then you end up squaring it to get, you end up squaring it, and then, I got this out of order. You square this, and then you multiply it by G. So sometimes written like this, GT squared over 2 over 4 pi squared. G is 9.8, pi is pi. T though, T is what they told you. T is the 10 seconds in this in this. So the fact that the
9.8 is 98. on top?
You might want to got a few more decimal places than that, but it's 9.81. Yeah. So I got about 24.8 meters. It does say go to 2 significant figures, so you might go 25 meters.
That was correct. All right. I think that was everything I wanted to go over today, Matthew.
Great.
Thank you very much
Thanks for
help.
scheduling. Sorry about the issues getting started. I'll send these
That's okay.
notes out here in the next couple hours. Thanks a lot.
Thank you so much. Have a
See you
nice
next time.
night.
Bye
Bye-bye.
now.